Hello everyone! For today's video, we will know more about interpolation, such as piecewise cubic spline interpolation, piecewise linear interpolation, and polynomial Newton interpolation. We will solve the interpolating values using Microsoft Excel. But first, let us define interpolation.
Interpolation is the estimation of value from certain known values of the function. For example, we have problem 6.4 from the book Elementary Principles of Chemical Processes. The vapor pressure of ethylene glycol at several temperatures is given below. Estimate the vapor pressure at 110 degrees Celsius. I already solved the problem using Microsoft Excel, and I will explain to you how did I get these results. First, we have the Newton interpolation using triangular matrix. With Newton basis, we'll have a lower triangular linear system. Using the data in the problem, the system becomes this triangular matrix. The solution was then obtained using forward substitution. Given that we already have the coefficients, then we'll have now our interpolating function using Newton interpolation by triangular matrix. Second, we will solve for the interpolating function using piecewise linear interpolation. We have 6 data points in the problem, so with this, we will have 5 intervals. And in every interval, we'll have interpolating functions which can be solved through the general formula as shown. Substituting the given values, we'll now have the interpolating functions per interval, and combining all the intervals, we will have our interpolating function using piecewise linear interpolation. Lastly, we will solve for the interpolating function using piecewise cubic spline interpolation. We have 6 data points given in the problem, so with this, we will have 5 intervals, 20 equations, and 20 unknowns. The required interpolant is a piecewise cubic function defined by separate cubic polynomials in each of the 5 intervals. We can note this by the following equations. But first, we need to derive the 20 equations. Requiring the first, second, third, fourth, and fifth cubic to interpolate the data at the endpoints of 5 intervals, we will have the 10 equations. Requiring the first derivative of the interpolating functions to be continuous at t2, t3, t4, and t5, we will have 4 equations. Requiring the second derivative of the interpolating functions to be continuous at t2, t3, t4, and t5, we'll have again 4 equations. Finally, with the definition of a natural spline that has a second derivative equal to 0 at the endpoints, it gives the 2 equations. Now, we already have the 20 equations. Let us solve for the 20 unknowns. By substituting the given data in the 20 equations and simplifying it, we will have these equations. Writing out the 20 equations into the matrix form, we'll get this matrix. But the question is, how can we solve for the 20 unknowns using the matrix? With this, we'll use the minverse function that returns the inverse matrix for a matrix stored in an array. So our array will be the matrix above. With this, we'll have another matrix. After using the minverse function, we'll use the mmult function that returns the matrix product of two arrays. The two arrays are the matrix above. After that, we'll already have the solution for our 20 unknowns. Again, the required interpolant is a piecewise cubic function defined by separate cubic polynomials in each of the 5 intervals. Substituting the solution to the 5 polynomial equations, we'll have our interpolating function using piecewise cubic spline interpolation. In summary, these are the interpolating functions using Newton interpolation by triangular matrix, piecewise linear interpolation, and piecewise cubic spline interpolation. But the question now is, which interpolant gives more reasonable values between data points and why? Again, using Microsoft Excel, we'll graph the interpolating functions. As you can observe in the graph and the data, we have the Newton polynomial interpolation by triangular matrix, piecewise linear interpolation, and lastly, the cubic spline interpolation. Comparing these 3 interpolation methods, cubic spline interpolation gives more reasonable values between data points that is smoother and has smaller error than some of other interpolating polynomials. Going back to the problem, we have the following results of the vapor pressure using the 3 interpolation methods. But we can also estimate the different values at a given temperature. So for example, we'll change the temperature to 120 degrees Celsius. So our vapor pressure is equivalent to 40 mmHg, which is the same from the given data. And again, if we will change the intervals at 800 mmHg, so as you can observe, all the interpolating functions also change. So in conclusion, we can solve the interpolating functions using Microsoft Excel. That's all, and thank you for watching.